Hey everyone, and welcome back to the channel. Today, we're diving into a topic that might sound a bit technical, but it's super important for anyone dealing with electrical systems: harmonic currents. So, what are they? Think of them as electrical pollution. They're extra unwanted currents that distort the smooth sine wave of your AC power. These distortions can cause all sorts of problems, like overheating equipment, tripping circuit breakers, and even damaging sensitive electronics. But don't worry, managing them is totally doable. Let's break down 8 key steps to get your power quality back in top shape. First up, you need to play detective and identify the source of the harmonics. The usual suspects are nonlinear loads. This includes things like computer power supplies, LED lighting, variable frequency drives, and even EV chargers. Using a power quality analyzer is the best way to pinpoint exactly where these troublemakers are coming from. Once you know the source, you can target your solution effectively. Step 2 is using passive filters. These are one of the most common and cost-effective solutions. A passive filter is basically a combination of inductors and capacitors, tuned to a specific harmonic frequency. They create a low-impedance path that diverts the harmonic currents away from your main power system. Kind of like a drain for electrical noise. They're great for situations where the load is constant and you're targeting a specific harmonic. For more complex or dynamic situations, you'll want to look at Step 3. Active harmonic filters. Think of these as the high-tech version of passive filters. Instead of just diverting harmonics, an active filter monitors the line, detects the harmonic distortion in real time, and then injects an equal and opposite current to cancel it out. It's like noise-canceling headphones for your electrical system. They are more expensive but incredibly effective, especially when your loads are changing all the time. Step 4 involves using phase-shifting transformers. These are special transformers designed to create a phase shift between their primary and secondary windings. By feeding different nonlinear loads from transformers with different phase shifts, you can cause some of the harmonic currents to cancel each other out right at the source. It's a clever way to use physics to your advantage. Next, Step 5. Improve your load design. Sometimes, the best defense is a good offense. When you're selecting new equipment, look for devices with low harmonic distortion. Many modern devices, especially those with a high power factor correction, are designed to produce fewer harmonics from the get-go. Investing in better quality low harmonic equipment can save you a lot of headaches down the road. Step 6 is a simple but effective strategy. Split your loads across phases. If you have a lot of single-phase nonlinear loads, like computers in an office, try to distribute them as evenly as possible across all 3 phases of your power system. This helps to balance the load and can naturally cancel out some of the triple unharmonics, which are particularly troublesome and tend to add up in the neutral wire. Moving on to Step 7. Consider using K-rated transformers. These are specially designed transformers built to handle the extra heat generated by harmonic currents. If you have a lot of nonlinear loads, a standard transformer can overheat and fail prematurely. A K-rated transformer is more robust and can safely operate in environments with high harmonic content, ensuring reliability and safety. And finally, Step 8. Maintain a good power factor. While power factor and harmonics are different issues, they are related. Poor power factor can worsen the effects of harmonics. Improving your power factor, often by adding capacitor banks, can improve the overall efficiency of your system and make it more resilient to harmonic distortion. It's all about creating a healthier, more efficient electrical environment. So there you have it, 8 practical steps to tame those pesky harmonic currents. By understanding and applying these strategies, you can protect your equipment, improve your system's reliability, and save on energy costs. Thanks for watching. If you found this helpful, give us a thumbs up and subscribe for more tips. See you in the next video.